There are some kinds of compressors: reciprocating compressor, rotary screw compressor, axial flow compressor, centrifugal compressor, and mixed flow compressor. Reciprocate Reciprocating compressor. A reciprocating compressor is a positive displacement compressor that uses a piston driven by a crankshaft to deliver gases at high pressure. What is a crankshaft? So a crankshaft is basically a part of an engine that translates reciprocating linear motion into rotation. As you can see in the figure, the crankshaft is in red, the piston is in gray, their cycles are in blue, and the flywheel is in black. Construction of reciprocating compressor. A reciprocating compressor is widely used in gas services. The basic design consists of piston in a cylinder where the pressure actuated check valve is used to control suction and discharge flow through a cylinder. In a double acting system of a gas is compressed on the both sides of the piston. A dictionary defines a reciprocate means something to alternate back and forth. A reciprocating compressor uses a reciprocating action of a piston inside the cylinder to compress the refrigerant. As you can see in the figure, as the piston moves downward, a vacuum is created inside the cylinder. Because the pressure above the intake valve is greater than the pressure below it, the intake valve is forced open and the refrigerant is sucked into the cylinder. After the piston reaches its bottom, it begins to move upward. The intake valve closes and the refrigerant moves through an exhaust valve. As the piston continues to move, it compresses the refrigerant and increases the pressure. Once the piston reaches its topmost position, it starts moving downward again. Reciprocating compressors are available from 1 to 6 pistons.
Rotary screw compressor. This is a type of reciprocating compressor. The screw compressor are used instead of piston. Construction. It consists of inlet, check valve, screw or gears, thread, outlet or discharge. Inlet. The gas is injected through inlet. Check valve. It controls the motion of flow. It only open with the flow pressure of fluid. Screws or gears. There are two gears used to compress the gas. They rotate by the motor or other electrical source to produce rotational velocity of gas. The timing gear ensure that male and female rotor maintain precise alignment. Thread. The flowing gas passes through thread section and be compressed. Outlet. The compressed gas discharged by outlet. Working. The gas enters through inlet. The screws rotate and produce rotational kinetic energy of gas and move the gas through thread. In thread section, the gas is being compressed and discharged through outlet. Application based categories. There are two categories, the oil free and second one the oil flooded. In oil free compressor, the gas is compressed only by screws without assistance of oil seals. In multi-stage compressor, the air is compressed by several screws. The maximum pressure output is 150 psi gauge and the volume output is 2000 cubic feet per minute. Advantages. Leakage. Low leakage, parasitic losses, prices, performance and maintenance. Low leakage. The fluid cannot drop back to the suction inlet due to the close meshing of gear. They have low parasitic losses. They have low prices. They are high performance compressor. They occupy fraction of space. They require a minimum of operating attention and maintenance.
Okay, now we have axial flow compressor. There are three main things: construction, working, and performance. In the axial flow compressor, the air flows parallel to the axis of rotation. The compressor is composed of several rows of airfoil cascades. Some of the rows, called rotors, are connected to the central shaft and rotate at high speed. Other rows, called stators, are fixed and do not rotate. The job of the stator is increase pressure and keep flow from spiraling around the axis of bringing the flow back parallel to the axis. In the figure on the right, we see a picture of a rotor of an axial compressor. The stators of this compressor are connected to the outer casing, which has been removed and is not shown. At the upper left is a picture of a single rotor stage for a different compressor so that you can see how the individual blades are shaped and aligned. At the bottom of the figure is a computer generated figure of the entire axial compressor with both rotor and stators. The compressor is attached to a shaft which is connected to a power turbine on the right end of a blue shaft. Now the main question is, how does axial compressor work? The details are quite complex because the blades, geometries and resulting flows are three-dimensional, unsteady and can have important viscous and compressibility effects. Each blade on a rotor or a stator produce a pressure variation much like a airfoil of a spinning propeller. But unlike a propeller blade, the blades of an axial compressor are close to one another, which seriously alters the flows around each blade. Compressor blade continuously pass through the wakes of upstream blades that introduce unsteady flow variations. Now we have performance. Compressor designer must rely on wind tunnel testing and sophisticated computational models to determine the performance of an axial compressor. The performance is characterized by the pressure ratio across the compressor CPR, the rotational speed of the shaft necessary to produce the pressure increase, and an efficiency factor that indicates how much additional work is required relative to an ideal compressor.
Centrifugal compressors. Centrifugal compressors use a rotating disc or impeller in a shaped housing to force the gas to the rim of impeller, increasing the velocity of the gas. Unlike reciprocating compressors, centrifugal compressors are a steady flow device, hence they are subjected to less vibration and noise. Centrifugal compressor achieves a pressure rise by adding kinetic energy or velocity to continuous flow of fluid through the rotor or impeller. This kinetic energy is then converted to an increase in potential energy or static pressure by slowing the flow through a diffuser. Now further explain the working principle of centrifugal compressor. A simple centrifugal compressor has following components: inlet, centrifugal impeller, vanes or blades, diffuser, and last one is collector. Inlet. The inlet to a centrifugal compressor is typically a simply pipe. Low pressure refrigerant or gases enters the compressor through the eye or inlet of the impeller. Number 2, impeller. The key component that makes a compressor centrifugal is the centrifugal impeller. It is the impeller's rotating set of vanes or blades that gradually raises the energy of the working gas or refrigerant. Vanes or blades. Impeller is consist of number of blades. From the eye, the refrigerant enters the flow passages formed by the impeller blades, which rotate at very high speed. As the refrigerant flows through the blade passages toward the tip of impeller, it gains momentum and its static pressure also increases. Diffuser. From the tip of the impeller, the refrigerant flows into a stationary diffuser. Downstream of the impeller in the flow path, it is the diffuser's responsibility to convert the kinetic energy, having high velocity of the gas, into pressure by gradually slowing or diffusing the gas velocity. Collector. The collector may be termed as volute casing. As the name implies, a collector's purpose is to gather the flow from diffuser's discharge annulus and deliver this flow to a downstream pipe. This is further illustrated in the diagram. Now there is further applications of the centrifugal compressor. It is used in gas turbines and auxiliary power units. It is also used in pipeline compressors of natural gas to move the gas from production site to the consumer. In air separation plants to manufacture purified end product gases. And last one, it is also used in oils refineries, natural gas processing, petrochemical and chemical plants.
Mixed flow compressors. Mixed flow compressors are also known as diagonal compressors. These compressors are similar to centrifugal compressors. In this type, the compression process is part axial and part centrifugal. Now we have the history of mixed flow compressors. The design of mixed flow compressors has not developed as comprehensively as axial compressors due to structural limitations and computational capabilities. But in recent years, the design of mixed flow compressors has developed many folds due to rapid progress in computational techniques, computational power, and better understanding of the flow physics. Most of the pioneering work in the design and analysis of mixed flow compressors started in 1940s and 50s. Work presented by Austin King in 1942 was probably one of the earliest works regarding mixed flow compressors. After some years, Loskin and Kovsky investigated a mixed flow compressor stage with vaneless diffuser. The first document for the design of mixed flow compressor was that described by Goldstein. In 1975, Wallace presented computer-aided design procedure for radial and mixed flow compressors. Now we have the working of mixed flow compressors. Mixed flow compressors are quite similar to centrifugal compressors, but the flow tends to exit in an axial rather than radial direction. This eliminates the need for a relatively larger dia exit diffuser associated with centrifugal compressors. The diffuser is often used to turn diagonal flow to an axial rather than radial direction. The impeller can be machined from solid using NC machines, in much the same way as that of a centrifugal compressors. So far, only a few examples of these units have been tested worldwide. Now we have advantages of mixed flow compressors. These compressors offer the advantage of a relatively high pressure ratio per stage, without the need for a relatively low dia exit diffuser, which can cause installation problems. Now, the applications of mixed flow compressors. Thanks to the topping quality, new structure, and easy installation, it is widely used in factories, mines, hotels, and underground facilities of tall buildings, as well as the distant series installation in relatively long vent pipes so as to increase the full pressure in the pipe. And that's the end of our presentation. Thank you.